Welcome to the EDX3160 Assignment 1 presentation of VictoriaMorrad. This presentation focuses on Year 5 Physical Sciences concept of light. With special interest in the Australian Curriculum Content Descriptor ASSU080, light from a source forms shadows and can be absorbed, reflected and refracted. Through the study of the Physical Sciences unit exploring the phenomenon of light, students will expand their understanding of light sources, how light travels to the eye, and the transmission of light. Light originates from a range of sources. These sources can be natural, such as the sun or a candle, or artificial, such as a light bulb, torch, or television screen. Light originates from a source, is detected by the eye, where that information is translated by the brain into the image. When light reflects off an object back to the eye, we can see the object. Without reflection, refraction, or diffraction of light off objects, they cannot be seen. The absence of light means objects are unseen, but they do not cease to exist. In the 1983 study of student misconceptions about light, a comparative study of prevalent views found in Western Australia, France, New Zealand, Sweden and the United States, Karkvist and Anderson, as published by Featherstone, Howe and Traegast, 1987, concluded that the misconceptualized idea of a visual ray, that is, something being emitted from the eye, was held by many of those students studied. Featherstone, Howe and Traegast, in explaining the visual ray phenomenon, further surmised that some learners thought that seeing was an active eye process with something leaving the eye rather than entering. It is apparent in this study that the misconception of the visual ray develops where there is little to no understanding of the mechanics of light and of the eye itself. This can occur when students have very limited experience with absolute dark or an absolute absence of light. When a student experiences what they consider dark at night in their bedroom, there is often still some source of light, allowing a misunderstanding to develop that there is no requirement of the presence of light to reach the eye for the brain to see objects. Students can engage with a range of picture cards to classify items as a source of light or a reflector of light. Extended understanding of light sources can be developed through engaging in classification of light sources as natural and artificial. Construction of a TWLH chart allows students to express their own understandings of light phenomenon. This is a good way for teachers to ascertain where students hold valid or invalid notions around the concept. As a group, the class will contribute ideas to the what we think we know and what we want to learn columns prior to deep exploration in the learning unit. The what we learned and how did we know columns will be completed during the evaluation phase of the learning. Through discussion led and guided by the teacher, the class can devise how to depict the process of light transmission from the sun, reflecting off an object, then travelling to the eye to be detected and seen. Arrows are used to indicate the transmission of light through this process. Design thinking is a dynamic 5-phase process to generate creative solutions to a problem. Students are naturally creative thinkers and as a result are well equipped under the right conditions to producing a range of innovative ideas and solutions. Due to the fluid nature of design thinking and the 5 E's of science instruction, these pedagogies can be very closely aligned. In design challenge thinking, empathize or understanding the audience can be affiliated with the 5 E's engagement of learners to motivate their interest and curiosity. Define in design thinking can correspond with exploring and explaining in the 5 E's process, whereby learners will express their understanding in both before and after engaging in the learning series. When students ideate as designers, they begin to explore and elaborate on their emerging perceptions. The prototype phase of designing aligns itself with the explore and explain sectors of 5E pedagogy. Finally, the test action is interchangeable with explore, explain, and evaluate directives of 5E learning. Step 1 of design challenge thinking is to empathise or understand the audience. This can be affiliated with the 5E's engagement of learners to motivate their interest and engagement. Using activities 1.1 and 1.2 to begin tuning students' thinking into the concept of how light works in enabling us to see objects, children are beginning to gather and order their understandings. From this activation of knowledge and with focused discussion of what we want to learn, the group can then be guided to forming the question, how do we know the eye receives light for us to be able to see objects? Step 2 in the design challenge process is exploring, or prototype and testing. The phase of ideation also lines up with exploring, as it is a time of brainstorming to develop creative solutions to the inquiry question being posed. This also defines the process of gathering the information needed to answer the overarching question through exploration. When planning the investigation, teachers should present students with guiding questions to develop ideas for how to answer the inquiry. How will we isolate the eye to test the directionality of light movement? How will we eliminate external light from entering the eye? What is a fair test? What materials are readily available in the classroom to conduct a fair test? What variables need to be considered to conduct a fair test? From this train of thought, a range of options for investigation can be generated. The teacher can then steer the investigation towards the planned experience. Of course, if a better plan is developed, this is the ideal time to think and act flexibly and be open to conducting parallel studies to explore the concept. When the process of investigation has been decided, students should be invited to decide upon the variables that will be separately changed and tested. These may include, but are not limited to, wholly covering, uncovering, or partially covering the opening to change the amount of light let into the tube, poking or punching holes in the tube to allow smaller amounts of light in from another area than the end of the tube. After guiding students toward the planned procedure or an alternative of their own design, a written method should be developed in designing a prototype. Students should assemble the required materials, which they then begin testing. Students will use black cardboard and sticky tape to make a cylinder about the size of their own eye socket, but large enough to fit a small object inside to act as a focal point. For safety, it is recommended that while students work in small groups in constructing their experimental objects, that they make a unit each, so minimising the risk of inadvertently bumping each other's eyes or potentially contaminating objects that will be in close proximity to the eyes. With the current threat of COVID infection as well as other already known pathogens, individual implements are preferable. To keep the investigation appealing to the student participants, use of high-interest objects such as Lego minifigures or other similar novelty items will capture the attention and further motivate involvement in learning. Following the agreed process, students will then use the tube they have fashioned to begin testing the question, how do we know the eye receives light for us to be able to see objects? Holding the cylinder to their eye with one hand, using the other hand to cover the open end of the tube, students can now observe the phenomenon of an object being unseen due to the absence of light. Students can remove their hand wholly or partially to allow light into the cylinder to see the object again. As students move through the process of changing a variable at each point of testing, they can discuss and compare their findings with other members of their group. Explaining or defining their experience as engaging and exploring, students will begin to draw conclusions about the phenomena they observed. Support to ensure students are addressing the guiding questions in their answer to ensure the development of appropriate understandings. Revisiting the TWLH chart at this point allows broad discussion about what was observed, what has been learned, and how we know that we are accurate in our summations. When students ideate as designers, they elaborate and explore while beginning to consider how does this information apply to everyday life. Using the TWLH chart as a reference point, students can begin to merge what they now know with how this learning impacts upon and can be used in everyday life. The final phase in this design challenge activity is evaluation. Where design testing aligns well with the 5E evaluation as a stage in the process, testing as a design step is similarly represented in the exploring, explaining, and elaborating components of 5E methodology. In this period, students will reflect on what they already knew prior to the commencement of the learning cycle, what they have learned throughout the experience, and share their ideas with each other to exchange feedback.